But we just kept working together, first getting rid of the wires and then getting rid of the separate transmission device on the horse's back. During this time, we also made significant advances in the data analysis. We were aided during this time by advances primarily in battery and radio technology, such that our first wireless version looked something like this. It consisted of 4 self-contained sensors with the sensor, battery, radio, antenna all in one device, sending live, synchronized data to a receiver box connected to a laptop computer. We later determined that the information provided by the gyroscopic sensor placed on the right hind limb was redundant. It did not provide any additional information that was not provided for by the right forelimb gyroscope, so this sensor was dropped from the system, and actually our current setup requires only 3 sensors. About this time, we needed and started to look for outside funding, including private investor funding, which we did acquire, but more significantly, we acquired the support of the National Science Foundation. They, their scientists and engineers, evaluated our idea, the need in the profession, the fault detection approach, the sensor construction and development, the business model, and agreed that the approach was fundamentally valid. I have heard and read that some veterinarians think of our system as some kind of gadget based on some translated technology used in another industry for some other loosely related application, but without a sound scientific basis. And I realize there are a lot of gadgets out there like this in our industry, but the National Science Foundation is unlikely to support the development of a gadget. This brings us to the year 2008. With the help of NSF funding, we constructed our first units, sent them for testing to 6 early adopters, and made further adjustments and improvements with the help from a few of these sites. Soon after, we sold 9 units to beta testers basically at cost. Here is one of those units, which we now call our Generation 1 system. Some of these systems are still in regular use today. The sensors were a little bulkier than they are now. They were turned on with a little push-button switch, which tended to break after much use. There was a prong and hole-based battery charging mechanism, which was not ideal for dirt and moisture conditions commonly seen in the lameness evaluation environment. The head sensor was attached to a head bumper worn by the horse, although it could also be simply attached to the crown piece of the head halter. The right forelimb gyroscopic sensor was attached to the right forelimb with a felt pastern pouch wrap, and the pelvic sensor was attached with a short strip of 3M dual lock tape and then secured with additional tape. We were able to replace the receiver box with a simple USB receiver with antenna, and we switched to tablet PCs instead of laptops because sand and dirt in riding arenas are not very friendly to laptop keyboards. Using data from these sites and incorporating suggestions for improvements, we further improved the sensor design, wrote additional interface software, improved the fault detection algorithms, made other miscellaneous improvements, partnered with other companies, a software development company, surface mount manufacturing firms, to develop our first commercial unit, which was rolled out at the AAEP meeting in Las Vegas in 2009. We currently have over 75 units out in use in over 20 veterinary teaching institutions. Most users are private practices. Some are large referral practices with in-house facilities, and we also have clients who are smaller ambulatory-only practices. We have units in the United States and internationally: Canada, Sweden, Scotland, Ireland, Brazil, France, Germany, and I may be missing a country or two. We have users that are relatively young veterinarians, early in their careers, and older, and also older, seasoned, and very experienced equine lameness clinicians.